This is from when I missed last class.
Okay, thank you.
Yeah, thank you.
Doors open. This.
Did you start your project?
I found a couple pictures. But I haven't found the drawings.
What are you gonna draw?
Something that represents like one of them. Each and one of them, I guess.
Let's do Friday.
So let's all get the
Well, we have the class to do it. Alright, no more cookie clickers, right? We're doing these two the entire class.
That's what happened. So this was gonna take most of our time.
I pretty much flew through the videos. They were really dope. Their FAQs were pretty much exactly what we got. Except there was nothing wrong. It was like what should be
Goals, I turned in my project questions and she hasn't like very long.
Yeah. And he was like, yeah, I don't know. And I was like,
I
yeah.
don't think she got graded.
This year. Yeah.
She might grade it later, so.
She had a basket to turn in.
Not everyone's including me.
Bro, it's like yesterday. Yesterday.
I'm not certain when I get into class and start thinking about the school.
We have a good thing about they're so slow.
Why do they have so much? I could write that but we need to have something is connections to Amazon, information, scientific information, like pictures basically. Then it ran out just a statement. Why I chose to draw it that way.
Horizons. Science. Horizons, reformation, science.
Good morning, FHS. Please join me in a minute of silence. Please stand as you are able for the Pledge of Allegiance. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. I hope you have a wonderful Wednesday. Make sure those cell phones are in your yonder pouch along with headphones and earbuds. Make sure you're checking grades. We're definitely getting towards the end of the semester. Have a great day, and as always, go Purple Bottom.
All right, good morning, guys. So since we had a test last class, we are also near the end of the semester. So some of the stuff that we need to do to conclude our semester is we've got a couple random topics that I had skipped at one point for one reason or another. So that includes today's topic. So that will be mean value theorem. We also skipped two other topics called tangent line approximations, that'll take us today, and one on L'Hopital's rule, which you will like. That's one of the favorites for students because it makes limit questions quite a bit easier. We will dip our toes into a little bit of what the next unit looks like, even though we don't have time to finish it and test it. I mentioned a few weeks ago that our next unit, the one that we will test in January, for most students is the hardest of the year. The good news is it's followed up by probably the easiest of the year. But one way I can try to make it a little bit easier for you is to preload you and get some of the information under your belt before we leave for winter break. So that's pretty much our time left. So mean value theorem that we're going to start on today. This is a big one. And honestly, it really is supposed to be on the test you guys took last class. It fits in that unit. But I feel like that unit has enough stuff to it already that if I squeeze mean value theorem in there as well, it's just kind of unnecessary. But this is a very important topic. So this is the last of the big three theorems. The first one we did was intermediate value theorem. That was like week 1 or 2. We did extreme value theorem last unit, and now mean value theorem. So today will be the only day that we spend the full class period on this, on mean value theorem. But I do need to quiz you and give you a major grade for that. You need to have assessment grade points for that. So before we leave for Thanksgiving break, you can see over there I will give you a 10-point quiz. but that quiz will only be on mean value theorem, just this one topic. So I feel like that should be good news for you, because only having to worry about one topic is, of course, a lot easier. Okay, so what mean value theorem says, and actually, if you just think about the name, you've got some idea. When they say mean value theorem, they're not saying the opposite of nice. What does mean often mean in math? Average. So what the mean value theorem says is if the conditions are met, and the conditions are important, so let's highlight those. It has to be continuous from A to B, closed interval, and it has to be differentiable from A to B on the open interval. So if it's differentiable at A and B, that's great, but it doesn't have to be. It does have to be continuous at A and B, though. All right, the mean value theorem says, so here's the math definition, says that there's a point C, so there's an x value C that's between x equals A and x equals B, such that the instantaneous rate of change, which we know means derivative, is equal to the, remember means average in math, the average rate of change, which is just really the slope formula. So if you have a continuous differentiable function, there has to be at least, the mean value theorem guarantees there's at least one time when the instantaneous rate of change equals the average rate of change. That's all that mean value theorem says. Now, in a lot of ways, that doesn't sound intuitive, but when you see a few examples of this, it should kind of, I think it should make sense to you. Okay, so here's what most of the questions are going to look like. So I'm just going to dive into a question and then we'll backtrack and talk about why did those conditions have to be true. So a typical question would say, find the value C that the mean value theorem guarantees for this function during this interval. So you would have to say, okay, well, mean value theorem says the derivative, so you'd have to take the derivative, is equal to the average rate of change, which is just really the slope formula. So f of 2 minus f of negative 2 over 2 minus negative 2. And all that mean value theorem says is that this has to be true for at least one value of x. Maybe multiple x's, but it has to be true at least once. So if your job is to find that C value, then you have to go through this arithmetic and you have to solve this equation. So f of 2 means we're plugging in 2 into the function and getting, I don't know, negative 16 plus 12 minus 2 is that negative 6? Does that sound right? Okay. And then f of negative 2 would be negative positive 16 minus 12 minus 2, which would be 4 minus 2, which is 2. That sound okay too? Thank you for checking. Over 4. So we get negative 6x squared plus 6. Negative 8 over 4 is negative 2. And then basically I'm solving a quadratic now. I could add the 2 over. Anytime you solve a quadratic, you want everything on one side set equal to each other. And then 99% of the time you solve a quadratic, you're probably either going to be able to factor it or do quadratic formula. This one, does not factor nice, but we don't need quadratic formula either. We can just solve this like a normal equation. Subtract the 8 over, divide both sides by negative 6, and then take the square root of both sides. Okay. That's close to being correct. Very good. If you're going to take the square root of both sides, you better remember plus or minus, or you lost half your answers, even though you did all the work. So, there we go. There's 2 times where the average rate of change, which is basically what you learned from the slope formula, is equal to the instantaneous rate of change, which we get from the derivative. Now, I'm going to slide over and look at this picture here for a second so you can kind of see what we're saying. If you understand this picture to the right, then you understand why the mean value theorem has to work. Okay, so we've got a function. Notice it is continuous. There's no breaks in the graph. It's this blue one. There's no breaks in the graph, just some function. It's also differentiable. There's no cusp, there's no sharp points, so I can take the derivative anywhere I feel like it. So the average from A to B would be, this is when we did the slope formula. Basically, this. How much does it go up or down over how much time? On average, how did it go? For instantaneous, we know the instantaneous rate of change. We often visualize that with tangent lines. So right here, this kind of shows his instantaneous rate of change. Right here, his instantaneous rate of change is about that, about that. But if this is the average rate of change, whatever this number is, whatever this slope is, there has to be this at least one time that we tend to call C, where at that instant, the slope of the tangent line is equal to the average. You just need to think about how these are parallel, so they've got the same slope. So that's all it's saying. If your graph's not jumping around, being unpredictable, no sharp turns, then the overall rate of change has to occur at least one instant. So sometimes it could be more, sometimes it could be less, but there has to be at least one time where this slope equals the average slope. And so again, this is the bulk of what the questions will look like. So I'm just kind of throwing you into it on question 1. If you're asked to find C, this is the most involved thing in mean value theorem. You've got to take the derivative, instantaneous rate of change, set it equal to the average rate of change slope, do the arithmetic, solve your equation. It's always going to be something that you can solve, or you'd have access to a calculator. And then sometimes you do need to think about, if you really only care about -2 to 2, if one of these numbers was 10, I wouldn't include 10, because I don't care about 10 if I only care about -2 to 2. But both of these fall within that, so that's fine. Now, I want to do one more quick visual of what we just did, because I would like you to see from your calculator what I am trying to say. Again, understanding the visual is really all that's needed for mean value theorem. Okay, I'm sorry, my eyes are too old. Can y'all tell me what that function is? -2x cubed
Plus 6x
minus 2. Okay, like that. Okay. Okay, so here was the made-up function we were looking at or working with in example 1, and I was only asked to worry about values from -2 to 2. So the right side of our equation, we did the slope. If we just take the starting point and the ending point and think of the slope formula, that's what we just found right here. And that value was -2. So notice my line's going down, so negative slope. So this, actually, let me see if I still have this. I don't know if this will work, but okay, let's try this. Okay, so this represents the average rate of change, the slope formula. And what mean value theorem says is there has to be at least one instant where the instantaneous rate of change is the same. So we got two answers. We got plus or minus the square root of 4/3, and the square root of 4/3 as a decimal is about 1.2. So notice at about 1.2, notice how the slope here, the derivative, the instantaneous rate of change, is the same as the average. So it guaranteed it would happen at least once, but sometimes it can happen more than once. And so we actually just found those two values by doing that arithmetic. Okay, so why did the conditions matter? So let's try to come up with a few examples here. And I'm not great at this, so I might have to give it a couple tries. But let's say if we had a function that is not continuous, let's say it does like this, and then it does like this. Actually, let's just make it simpler. Let's just do this and this. Okay, this is not continuous. So if I tried to do the average rate of change, taking this point and this point, is going up 0, it's going right however much that is, but the average would be 0. And then there's nowhere, the slope is either something positive or something negative. There's no time where the slope has to be 0 at any instant. And that's because of this discontinuity. So again, a lot of calculus stuff only works if the function is fairly predictable. If the graph has random breaks in it, then it's not predictable. Most of our calculus doesn't hold up if that's the case. Okay, and then I can use basically the same picture for differentiable. So let's make an example that's not differentiable. Again, I'm just going to pick one that has an average rate of change of 0. And this time I'll make it continuous, but I won't make it differentiable. It's not differentiable here because that's a cusp. Your instantaneous rate of change cannot change drastically like that. It has to be a slow change over time with curvature. It cannot, so the average rate of change is 0. So if it was not differentiable, you can see that this doesn't work because sometimes the slope is positive, sometimes the slope is negative, but never is the slope 0. The slope's not 0 here, the slope is undefined there. So that's just a quick example as well. So has to be continuous from A to B, include A to B, and then it has to be differentiable from A to B, and you don't have to include A to B. So hopefully that helps you understand why those are so important. Okay, we got a couple more examples to look at, and then I have one practice AP question I want you to look at on the back. And then we can get all the practice that we need, because honestly, after you do a few of these, it's the same thing over and over. If conditions are met, you take the derivative and set it equal to the slope formula. Derivative equal to the slope formula. Derivative equal to the slope formula, and then solve, depending on what you need. Now, there is this term, and you may want to write this in your notes just so you don't worry about it in the future, but for your AP exam, you do not have to know this term, Rolle's theorem. They will not ask you about Rolle's theorem directly. They won't use the words Rolle theorem. But as math people, typically you guys like to know this stuff. But Rolle's theorem is actually just mean value theorem. So if you know mean value theorem, you already know Rolle's theorem. It's just that Rolle's theorem is a very specific case of mean value theorem. It's the case of mean value theorem when the derivative has to equal 0, when the average rate of change is 0. That's the difference between Rolle's theorem and mean value theorem. Again, Rolle's theorem is still considered mean value theorem, so it's not anything new. But basically, the two examples I gave to you on your back page, or front page, these were technically Rolle theorem problems because the average rate of change was 0. But okay, so let's look at two examples of this. And again, we're not necessarily even need to refer to it as Rolle's theorem. Those of you that like to do math contest stuff, though, then you would need to know this name. But okay, so find all numbers C guaranteed by Rolle's theorem for this function from 0 to 4. Make sure that we can check the conditions of Rolle's theorem. So Rolle's theorem is just mean value theorem, so whatever has to be true about mean value theorem has to be true about Rolle's theorem. So it has to be continuous from a to b, including the endpoints, which this is. Polynomials are always continuous. This is a polynomial. And it has to be differentiable from 0 to 4 on the open intervals. And you look at that function, you can take his, maybe you need to take his derivative before you felt comfortable saying that. But the derivative would be 2x minus 4. That's never undefined, so you can find the derivative for any x value. The derivative exists from negative infinity to positive infinity, but it certainly exists from 0 to 4. Okay, and then, so mean value theorem holds up, or the conditions are met, aka Rolle's theorems are met. So now we want to go and find that value c that's being guaranteed by mean value theorem. So when does the instantaneous rate of change derivative equal the average rate of change slope? So you're going to have to do f of 4 minus f of 0. Make sure you're doing the subtracting the y values. That gives you rise. Divide by the run. Subtract the x values in the same pattern. And what happens when I plug in 4? What do I get? (16 minus 16 plus 1 should just be 1, right? If I plug in 0, what do we get? So what is the average rate of change? 0. So again, if it just acts, if the average rate of change happens to be 0, that's the very specific case known as Rolle's theorem. But again, you don't have to know that to do this problem. You just do normal mean value theorem. Okay, instantaneous rate of change derivative equals average rate of change slope. You got to do that, and then you got to solve. Add the 4 over, divide by 2, and you would need to make sure that it's in between 0 and 4. So part of the weird part of the math definition is you can't include 0 and you can't include 4, but any numbers that's in that would work. So if I graph this, just show you 0 to 4, I'm just going to do it. I think it's too important for you to see the graph to not do it. Okay, so here was the graph, but this time we wanted x values from 0 to 4. Okay, so on the right side of our work, we found the average rate of change, which is this. We figured out that it was 0. Because the conditions for mean value theorem held up, that means that there has to be a time, there has to be at least one instant where the slope is exactly 0 at some instant. So just kind of, if you have the visual, you can see, here's the other time it looks like the slope is 0. And what we did is we just found that x value where it happened, x equals 2. That's when this average rate of change 0 was equal to the instantaneous rate of change 0. Okay, well, let's do that one more time, and then I want you to give it a shot on the multiple choice on the bottom. Okay, find all the numbers C guaranteed by mean value theorem for this function between 0 and 2. Make sure the mean value theorem is going to work. Okay, so it has to be continuous from 0 to 2, which it is because it's a polynomial, and polynomials are always continuous. I'm saying that if this was an FRQ, you really should say because I don't know, you don't have to say all, because polynomials are continuous. I'm not just guessing, I know it's continuous. There's no division by 0. There's no x's in the denominator to worry about discontinuity. Okay, and it needs to be differentiable from 0 to 2, not including the endpoints. So I might want to see the derivative. I I'm going to need it in a second anyway, to make sure that the derivative is never undefined between 0 and 2. It could be undefined at 3. That's not a problem. I only care about 0 to 2, not including those. And so the conditions are met. So I know the instantaneous rate of change derivative has to equal the average rate of change at least once. Instantaneous rate of change is derivative, average rate of change is slope. So this would be where you might want to be the most careful with your slope, because there's the most arithmetic here. Or maybe that's just me. 9, 17. Should be 5, I think. 0 would be 5. And then from 2 to 0. Okay, so because this ended up being 0, that's why you can technically call it Rolle's theorem instead of mean value theorem. But in the end, this is the equation we have to solve for C. Again, you need to know that term C, because that's what it's often referred to. So, like when I have you do like a Khan Academy, they might put C's there instead. Okay, and then what you should be left with is something that's pretty reasonable to solve, or it could be a calculator allowed question, but this is a quadratic, so it's probably going to factor this would be 2, 1. See, that would be -5, -1, like that. Okay, so then 2 and 1/3 looks to be my answers. But you actually are not going to keep one of these. Do you remember which one I said you wouldn't keep and why? Yeah. Again, I don't remember exactly. It's just like some weird exception part of the definition. You can't include any of the endpoints. So don't include 2 because it was on the end. So x equals 1/3. Now, I'm going to spare you because I've done a couple graphs here, but I would encourage you, if you have trouble visualizing this, graph this in your calculator, change your window from x equals 2 or 0 to x equals 2, so you can see the start and the end, and you can see the average rate of change. And then at x equals 1/3, at that instant, the slope is the same as the average slope. That's what we are trying to find, the location of that. Okay, I would like you to try this one. This was a real AP exam question, and again, I know I talked at the beginning of the year about BC students. 60% of their test is exactly the same as yours, so this was actually on the BC exam, but it's an AP topic. So look at their table, read their question, and see if you can figure out which one of those they're expecting you to pick. Okay, even if you're not finished, it's okay. It was just a practice question anyway. So, why does A, it says which one must be true? Why does A not have to be true?
Because 3.5 would be like really small number for some reason.
Right, so if you look at the Y values, it does look like the smallest Y value is 2, right? So that's what they're trying to trick you on. But you don't know what's happening between these values, right? So he's saying like you don't know what's at x equals 2.5, y might be negative 10 or something. You don't know what's going on between those. So there's no guarantee that that's the smallest value. And even if you thought that was true, then you should have been conflicted on the second choice. The max value is 4. Well, sure, it looks like the max value is 4, but anything could be happening between these integer x values, so that doesn't have to be true. Okay, does the y value always have to be positive? No, for the exact same reason. I don't know what's happening between 0 and 1. I know it starts at 2 and ends at 3, but it could go down to negative numbers during that time. Okay, this is saying that the slope, if the derivative's negative, the slope is always negative. So as you go from left to right, like you read a textbook, is our graph always going down? No, it's actually going up. 2, 3, 4, it's going up during those times. So the slope's not negative during that time. So process of elimination has to be E, but doesn't it also kind of stand out a little bit? It sounds like the definition. There exists a C, something between 0 and 4, where the derivative equals 0. Why does it have to be 0?
Because like change between the first y value and the second y value is also 0.
Correct. If you start at 2 and you end at 2, your average rate of change is 0. So this is like what they get from the slope formula. That's the average. And if mean value theorem holds up, then the instantaneous derivative has to equal that. How did we know mean value theorem has to hold up?
Continuous and differential.
Because of that, mean value theorem was fair game. Notice they didn't give you any hints. They didn't say, hey, consider mean value theorem, apply mean value theorem. But that's that. Okay, just for fun, before we slide over to the circuit and let you guys practice some of this and see what's going to go well for you and what's not going to go well for you. I've been doing really bad at giving you guys puzzles at the end of class, so I'll take a break. And I left a puzzle over there for you to look at. And I'd like you to think about that and see what you think. And we'll discuss that for a minute, and then I'll ask you to move on to the circuit. So what does your gut tell you? You think he's going to get a ticket for that?
Initially, I thought he wouldn't, but now that I looked at it, he does, because his average speed is 48 miles per hour. I think personally,
Okay, so you think he is getting a ticket or not?
I think he is.
Okay, let's think about this. There's 2 police officers that I'm going to draw as circles. They're 1.2 miles apart. I don't know, who cares about that. But a car passes by, and the first guy clocks him at 35 miles per hour. A minute and a half later, a second patrol car clocks him at 30 miles per hour. So they only see him doing 35 miles per hour and then 30 miles per hour. But the speed limit is 35 miles per hour. Right? So they never saw him go faster than 35 miles per hour.
His average speed was 48 miles an hour. Because
How do you, wait, how do you know his average speed was 48 miles per hour?
1.2 divided by 1.5, like 1.2 miles over 1.5 minutes, that 0.8 miles a minute, and then multiplying that by 60 gives you miles an hour. which
Good.
is
Make sure you
48
change.
miles an hour.
Okay. Your process is right. I don't remember if 48 is the correct number, but if his average. Okay, here's your two scenarios. Either he's going 48 miles per hour the entire time, like this,
Oh, I see what you mean.
or he's doing, instead of doing 48 miles per hour the whole time, sometimes he could be going slower for the cops to not see him, but if sometimes you're going slower, that means sometimes you've got to be going faster, right? Because the average has to be 48. If I'm just trusting your number, I don't know about that.
Oh, yeah. No, yeah, I get it.
So even though so this wasn't a random puzzle, I wanted you to think about this. They can, in court, prove that you went faster than 35 miles per hour, even though they didn't clock you at 35 miles per hour, because of mean value theorem. If they can figure out that your average speed during that time was 48 miles per hour, then they know at one instant, either at one long instant you just stayed at 48 miles per hour, or if you chose to go slower than 48 miles per hour sometimes, you had to go faster than 48 miles per hour other times so that your average was 48. Either way, they can guarantee that you were doing faster than the 35 speed limit. So, and now the police officers may not know it's called mean value theorem, but they can understand that principle, that that's how that works. Okay, thanks for humoring me there. Okay, so if you would go ahead and start with the circuit, please. And again, you're going to start to figure out pretty quickly that most of these questions are set the derivative equal to the slope formula, careful with the derivative, careful with the arithmetic from the slope formula, solve an equation. Derivative equals slope, solve. That's pretty much what you're going to just be doing over and over again. But of course they'll try to mix it up a little bit. You can see some of these, like the question under the first one has a calculator on it, so they're telling you to use a calculator there. You don't need to try to do the whole thing by hand. Oh, by the way, too, I guess I should have said this, and I do have a couple posters around the classroom about this. But what do we call these type of lines that touch your function at exactly once? Okay, those are tangent lines. That's a common thing in calculus. When it goes and it touches your function at more than one point, do you remember what kind of line that is?
Secant.
Very good, secant line. So the term secant line doesn't come up much on your AP exam, but I have seen it on some past questions. So the secant line is just the one that connects from beginning to end. It can intersect a circle, a function, whatever, multiple times, but the tangent line should just be brushing against it. So basically, you're trying to figure out when the slope of the tangent line equals the slope of the secant line. It is really what you're doing. So we don't have time to also go over this one today, but again, I need to give you a couple quick reminders here before we find a stopping place. So I am going to make an adjustment here. So I need to, again, warn you that before our Thanksgiving break, we will have a very short quiz that is only this topic, but it will go in as a 10-point major grade. So you could work ahead further on this circuit that I'm about to ask you to go, and you can prepare yourself early and get in extra practice if you want to make sure that you do better on that. But you do not have to come to class with 54 finished. We didn't get as far through it as I wanted to, but I would ask that you try to get through question 10, please. So if you finish question 10 and you feel like you did that correctly, no homework. Anything less than that, please do through at least question 10. I do have videos of all the first 10 questions, so if you get stuck on any of the first 10, you've got that to help move you forward. So I will ask you to do more of it later anyway, so if you guys have nothing going on during advisory today, it's certainly not going to hurt you any to go past question 10, but just question 10 as a bare minimum, please.